This is a tutorial for 6th grade science in Texas about kinetic energy of molecules in solids, liquids, and gases. First, let's talk about what a molecule is. Usually, when you see an image and it asks about molecules, the image shows circles or spheres. These circles represent molecules, or another term you might see would be particles. Matter is made up of substance that takes up space and has mass. So molecules are the little building blocks of matter. That's all it's referring to. I'm drawing a little Lego. That's what my intention for this little image to be, is a Lego, because Legos stick together to build bigger objects. So molecules or particles arrange themselves together to make up matter. Molecules have something called kinetic energy. Kinetic means motion. Little motion. So I'm moving my pen, it's getting bigger and bigger. The motion that caused this line would have low kinetic energy. Then, as my pen moved and I drew bigger and bigger, the kinetic energy increased until we had high kinetic energy. Now, why is this important? Well, molecules in a substance are always moving. They might be moving very little or quite a bit. They could just be vibrating in place, like molecules in a solid would. Maybe it's ice, like you have in the freezer or put in your drink. Maybe it's ice that's left outside and it melts. The molecules start to spread out because they have a little bit more kinetic energy. They're moving a little bit more, and you get a liquid. Instead of just vibrating in place, the molecules flow around each other. Then, let's pretend this is a hot, sunny day. And on this hot, sunny day, some of the water molecules evaporate and start flying around. The gas molecules have lots of kinetic energy. They're as if they're running away. So in this one image, we have shown a solid. You have seen an example of liquid and gas molecules. We've seen the low kinetic energy in solid molecules, medium kinetic energy in liquids, and high in gas. One more thing about kinetic energy in gases. They might be closer together and they might be really far spread out. If a substance is a gas, it has kinetic energy, but some still might have a little less than others, which have a lot and they're moving faster and farther. So even within a gas, molecules can have different amounts of kinetic energy. Now, let's talk about some of the language we use with solid, liquid, and gas. Matter has volume, takes up space, and it has mass. We are going to focus on volume, and we're going to focus on shape. Now, an example of shape would be a square, a cube, a sphere, a ball, a heart, a basket. The shape is the way something is made, like this tape has a shape. It's a circle. It's about 1 centimeter thick. It's hollow. And it also has volume. It takes up space. Solids have a shape that's not easily changed. For example, ice. Ice is a cube, or it's the shape of the ice tray it was formed in, and it doesn't change unless it goes through a change of state. So, we say that it has a fixed shape. And since the shape's not changing, the volume is also not changing. The same amount of matter taking up the same amount of space in a specific solid. Now, liquids are a little bit different. You draw like a cube real quick for a solid, a nice cube. And here's some water, waves for water for liquids. Liquids can maintain the same amount of volume. For example, in our class, we poured 50 milliliters of water into a sphere, and then we poured that 50 milliliters of water into a heart shape. The volume stayed the same. So we would still say that the volume of a liquid stays fixed. However, the shape of a liquid can change. It's not fixed. It's not definite. Another thing we need to talk about is gases. For a gas, I'm going to just draw some little dots. Maybe you could draw a cloud. Gases do not have a fixed shape or volume. I'm just going to write it changes. It's not fixed. There's other outside factors that can change the shape or the volume of an amount of gas. It's hard to manipulate those with the gas. So, do we see any patterns? We see that solids have both a fixed shape and a fixed volume. We see that gases have neither fixed shape and volume. And liquids have one of each. That is something to think about when you're answering test questions. Another word you might see instead of fixed would be definite. It's defined. Both of those words you might see for fixed. So now let's talk about some questions. Let's look at some questions and how we would approach them. Get it situated on the screen a little bit. All right, the liquid water in a kettle changes to a gas. So we're going from a liquid to a gas. as shown in the image here. So we're imagining there's a liquid in here, the molecules are close together, and they're escaping into a gas. Which of the following are true as water changes from a liquid to a gas? Select two answers. So I know a few things here. I know we're having a change of state going from liquid to gas, and that there are two answers. So when I read the questions, I've got to be in the mindset of liquid to gas and what is true or correct. The substance changes from having no definite volume to having a definite volume. So does a liquid have no definite volume? No. So I automatically know that this is not an answer choice for me. This is kind of backwards. Let's look at the next answer choice. The particle's kinetic energy increases. Well, I know that the particles, when it moves from a liquid to a gas, they spread out and they move faster. So I'm going to put a check here because I believe that's true. I'm going to wait and see what else the others say. The particles start to vibrate in place. Well, they're not starting to vibrate because they're already moving. So starting to vibrate might mean like it's not moving and then it starts to move, or it might mean that instead of flowing around, it starts to come together and vibrate. Either way, that's not happening. So I'm putting an X. The substance changes from having a definite volume to having no definite volume. So I'm going to underline my key things here, definite volume to no definite volume. So liquid does have a definite volume and gas has no definite volume. Okay, so I think that this is true. Let's read the last one just to be sure. The particle's kinetic energy decreases. Well, decreasing, I know, is when you go from a solid to liquid to gas is an increase in kinetic energy. And I'm going from liquid to gas, which is an increase, not a decrease. So now I know that this choice and this choice are my answers. Look at another question. The image shows ice cubes that were made by placing liquid water in a freezer. The liquid water changed into ice cubes, a different state of matter. Which of the following are true about water's change of state? Select all correct answers. Okay, so in this instant, we have a liquid that goes into ice, and ice is a solid. So I'm thinking liquid to solid in this question. And I'm looking for what is true. All right. The particles move faster in different directions when I go from a liquid to a solid. Are they moving faster? No, they're slowing down. So that's wrong. The particles moved faster in different directions. Did they move faster? No, we said they slowed down. The substance changed from having a definite volume to no definite volume. Well, liquid does have a definite volume, but no definite volume is a gas. So that one's incorrect. The substance changed from having no definite shape to having a definite shape. Well, I know that this is liquid and this is gas. No, I'm sorry, this is solid. I know I'm looking at liquid to solid, so this is correct. The particle's kinetic energy increased. Well, when we go from liquid to solid, it decreases. So I know that's wrong. And I'm just now realizing I made a copying error and missing one. And I know that the one I forgot to copy over was the particle's kinetic energy decreased. And I know that when we go from a liquid to a solid, they're spaced out a little bit, and then they're close together, and they go from flowing around to vibrating in place. So yes, it decreased. So my answer is the substance changed from having no defined shape to having a defined shape, and the particle's kinetic energy decreased. I hope this tutorial helped. Good luck.